Right, so let's take a look now as a general overview into what chemistry is really all about. Um, what we're trying to do here is what is referred to as a macro to micro. And what that simply means is material that we're familiar with, such as a pencil, it has certain properties to it. It can draw things. It makes a mark on paper. It has a certain color. It's erasable. Those are all called macro or large properties, and those are properties that we interact and can experience directly. However, what needs to be understood is that those macro properties like color or leaving marks on paper, they take place because of what the graphite is made up of. And how the graphite is made and what its chemical properties are and the bonds that are connected to it, those are called the micro properties. And so the properties of the pencil, the macro, is explained by understanding how the molecules that make up that material, which is the micro, operate. Now, to understand how these molecules that make up graphite work, we need to understand atoms and how they make up these molecules. And so that kind of captures what this course is all about. Understanding the physical properties we experience and explaining them at the micro or atomic level. Now, do atoms actually exist? Do they actually have a physical existence, or are they just these imaginary constructs? Well, up until somewhat recently, it was clear they existed, but we had no way of seeing them. Well, believe it or not, they have been seen. These are images of actual atoms. What you're looking at, the blue on the left, those are fluorine atoms, and the fluorine atoms are being moved around by a equally small item, which is referred to as a tunneling electron microscope. And it can actually move atoms around. If you look on the lower left, where there is this person, it's Atom Boy, and Atom Boy is literally made up of atoms which were maneuvered or placed in the shape that you see. If you look in the upper right, you will see another set of atoms. In this case, it's actually the electron clouds that you're looking at. So these are real images. They're actually physical representations of actual atoms that make up matter itself. This tunnel electron microscope was put together by IBM. So if we want to understand matter, which is what chemistry is all about, it's the study of matter and its properties. To understand it at the macro level, we got to understand molecules. But to understand molecules, you have to understand atoms, understand nucleus, etc., etc. So it's kind of a reductionist kind of approach. Always remember, what chemists are interested in is understanding the physical properties that we experience in the world around us. And to explain it, it does take the ideas of atoms and molecules. So what are the properties of matter? What are these macro properties we're talking about? Well, for one thing, matter comes in three states or phases. Matter comes as a solid, such as ice, and the molecules basically do not move around other than vibrate. Their position, generally speaking, is held in one place. You can have liquid is another state in which the atoms are able to slide past each other, but fundamentally do not have much separation between them. And the last one is you can have a gas. Notice when it comes to warm water, cold water, although they are both in a liquid state, cold water does have the molecules closer together, and therefore cold objects tend to be more dense. So states or phases are solids or liquids or gases, and that's a property that all matter has. Now, if you have a substance, whether it's a solid or a liquid or a gas, it's going to be made up of elements, or it's going to be made up of mixtures, or it's a mixture, or it exists as compounds. Within mixtures, the mixture is either homogeneous or heterogeneous, and with the homogeneous, you have solutions and colloid, and heterogeneous, you have what are called suspensions. Now, what we're going to do is we're going to walk through what it means to have a substance exist in elemental form versus mixtures versus the compounds. And you do want to know these definitions. You want to know examples of how these come together. Let's work our way through it now. What's an element? An element is a pure substance. For example, on the right, we're looking at a grill that's made out of gold. So gold is a pure element. It exists as just that kind of atom. And you have on the left diamond grill, and the diamonds are pure. They exist as pure carbon. So diamonds are pure carbon, therefore diamonds exist in an element form. Gold is a pure substance. Gold is an atom, and there's no other atoms involved. Now then you have a mixture. A mixture is having two or more different kinds of substances inside a container. Now, as we'll see, mixtures can be homogeneous and heterogeneous, but the take-home message right now is a mixture is two or more substances that exist in a container. Now, a compound is a molecule that's made up of two or more atoms. Now, in this case, caffeine, there's a variety of atoms that are involved. If it is two of the same kind of atom, it's still considered a compound. Now, in the summary on the left, it's pretty good. A mixture is several types of molecules located in one container. A compound is a pure sample of the same kind of molecule, and the molecule is made up of two or more atoms. And finally, an element is a collection of the same kind of atom we saw with the diamond and with gold. So now that we've understood what elements, mixtures, and compounds are, let's explore mixtures. Mixtures are either homogeneous or heterogeneous. Now, what does that mean? Well, a homogeneous mixture means the substances and the mixtures are in a single phase. For example, a cup of coffee. In that coffee, you have caffeine, you have perhaps sugar, you have perhaps liquid milk, and a whole host of what are called tannins, and then of course the coffee molecules that give coffee its taste. So there's a variety of molecules in there, but all of them are mixed evenly throughout the entire, in this case, in the entire liquid. You can have a homogeneous mixture of gases. The air around you is a homogeneous mixture, but it's in the gas state. Oxygen, carbon dioxide, krypton, all of those are spread evenly and everywhere throughout the gas container. That's referred to as a homogeneous mixture. But look on the right. That's a heterogeneous mixture. Notice those items are not evenly distributed everywhere. You have the sand, which is a solid set of grains. You have water, which is the middle. And of course, you have the oil sitting on top. You will notice in that container or beaker that all the items are not evenly distributed. Instead, they are located in specific areas, not uniformly. Therefore, that's a heterogeneous mixture. So now I got homogeneous and heterogeneous taken care of. Let's take a look at solution and colloids. So let's take a look at those two. A solution is when you have ions dissolved in water. In this case, you have Na plus and you have Cl minus. Those are actually salt, table salt, dissolved in water. So the solution has ions that are dissolved in them. And this situation is referred to as homogeneous because the ions are spread evenly throughout. Now, what are colloids? Colloids are solid material, but it's evenly distributed throughout. The photograph is unfortunately not very good. But milk has particulate types of oils and stuff like that that are spread throughout the liquid. So although it has a solid component to it, the solids are evenly spread everywhere and they'll stay that way. So it's referred as a colloidal. Cosmetics in the lower right, those are colloidal because you have the oil base that cosmetics have, but in those colloid base you have small particles that give it color. So the particles are solid, the oil is liquid, but the solids are evenly spread out everywhere, so it's referred to as a colloid. Blood is a colloid because the blood cells, red blood cells, white blood cells, those are solid objects, or essentially solid objects, but they are spread everywhere evenly throughout the watery plasma, and they don't separate from each other normally. Therefore, they're referred to as colloids. So we got those two, and that leads us finally to a suspension. A suspension is mixtures that are suspended in the liquid or the gas. Well, how is it different from a colloid? Well, suspensions do have solids suspended in the liquids, but if you give it enough time, the solids begin to settle towards the bottom. For example, you have, in this case, salad dressing, which is why you often need to shake it to make sure that the solid material at the bottom gets thoroughly mixed. So it is mixed throughout, but it will tend to separate on its own. Therefore, it's referred to as a suspension. Now, if you have a mixture of items, at times you want to separate what's in the mixture into separate pure substances. The classic example, think of having water and oil. That's a mixture. What if you want to separate the water from the oil and get the two separate from each other? Now, the ability to separate materials from each other in a mixture, that technique goes all the way back to the alchemists during the supposed Dark Ages. So let's take a look at how one does separate mixtures. One method is called the filtration method. And what we do here is you take a funnel with a filter paper, and what you do is you pour the mixture of liquids and solids. For example, one might imagine this to be an ocean water that has sand particles in it. You pour it through the funnel, and the filter paper retains the solid portion, which is the sand, but lets the liquid portion go through. So a funnel is a way, and filter paper is a way of filtering and separating the two based upon the mixture being made up of solids and liquids. Now, another way of doing this is to use a separatory funnel. In this case, what you do is you take two substances that are mixed together, two liquids that are mixed together, but they actually on their own separate. Oil separates from water. And so what you do is you pour the mixture of the two liquids into a separatory funnel. You let the two liquids naturally separate like oil and water will naturally do. And then what you do is you drain from the bottom the water. And that allows you to separate the two from each other. Now there's something called an evaporation method. What if you have ions such as salt dissolved in water? So you have a solution. Ocean water is a solution. It has ions that are dissolved in the water itself. If you evaporate the water away, then the ions remain. and you get the solid material out of it by evaporating the water out. There's another really important method of separation, which is called a fractional distillation. And this is a really important idea. When oil comes out of the ground, it's referred to as crude oil. Crude oil is a mixture of a very large number of types of liquids. Those liquids consist of butane, propane, kerosene, diesel, fuel oil, paraffin, wax, lubricating oil. All of those things are liquids mixed together in the crude oil. Now, we don't want to put lubricating oil in our gasoline engine. It would ruin the engine. Instead, we want to put pure either diesel or gasoline in. Well, that means we have to separate that liquid gasoline or that liquid diesel from all the others. To do that, the process is called fractional distillation. Now, what you do is you take the crude oil and you heat it up in a furnace. And that's what's happening in that green squiggly line. The crude oil is heated, and all of those different liquids, diesels, fuel oil, kerosene, petrol, all of those things turn to the gas state. So you change it from a liquid to a gas state. Now what you do, which is pretty slick, now you have these pipes. And the pipes are at different temperatures. At a temperature of 370 degrees Celsius, fuel oil leaves the gas state and turns to a liquid state. And so at that level of this long tower, fuel oil turns to liquid and it flows out of this big tower because it's turned to a liquid. But wait, at 300 degrees Celsius, which is a cooler temperature, now the diesel gases, they now turn into a liquid state, and now the diesel liquid begins to flow out. And of course, you could see that kerosene as a gas turns to a liquid at 200 degrees. So what they do is they turn all the crude oil into a gas, but then they push it into this big tower, and the different materials turn to a liquid at different temperatures. And they simply then bleed out or pull out the liquid form of just that material. Now, as you might imagine, this is all flammable gases, flammable liquids. So this is a very dangerous process. But this is how you have crude oil get separated into the different forms that we want to use it in, including petrol, which is the one you get for your car at the gas pump. So fractional distillation is a way of separating the liquids that are in a single liquid. Now, matter, whether it's a mixture or pure substance, whether it's an element or whether it's a homogeneous mixture, whatever all those things are, matter can undergo two kinds of changes. It can undergo a physical change, and material can undergo a chemical change. What's the difference? A physical change is when the material changes state, and this involves changing the temperature. So all things, crude oil, water, anything like that, if you lower the temperature enough, it's going to become a solid. If you raise the temperature enough, it all becomes a liquid. Of course, it all becomes a gas then. So physical changes are referred to as change in state, and they often involve a change in temperature. There's another kind of change which is called a chemical change. Here is where the material physically changes what it is. For example, If you burn gasoline, it turns into water vapor and carbon dioxide. The gasoline molecules have blown apart and they have reassembled into two new substances, which is water, carbon dioxide. So a chemical change is when you actually change into a new substance. And the way that happens is, it's at the very bottom that explains this, is that a molecule is made up of many atoms bonded together. During a chemical change, all those atoms in their bonds break apart, all the atoms separate from each other, and then they undergo recombining into new combinations. And these new combinations are new materials, new molecules, like gasoline into water and carbon dioxide. Now, the ship on the right, that's rust. Rust is a chemical change. How come? Well, that ship used to be made out of iron. It was pure iron. Oxygen is in the air, O2. Now, what happens is oxygen and iron come together and it makes a new substance. That new substance is called iron oxide. Iron oxide is what we call rust. So rusting is a chemical change because a new substance has been formed. So when matter changes, you got to ask the question, has it undergone a chemical change? And if it has, you have formed new kinds of molecules by breaking apart old ones and recombining the atoms. If, in fact, there's no new substance produced, then you're talking a physical change. When you sand a piece of wood, the very, very small sawdust is still wood. You didn't change the wood into new molecules. You just made it smaller pieces of wood. So that's a physical change. And, of course, melting. Coffee and sugar dissolving is interesting. When you dissolve sugar, the molecules of sugar separate from each other into individual sugar molecules. But the sugar molecules themselves do not fall apart and make new material. So dissolving is a physical change since no new substance is formed.